How could we prove this recursion on the Fibonacci numbers? We're going to do a proof by induction, and I'm actually going to fill in the base case at the very end. So first what we're going to do is plug in different values of n and see what it would say. For instance, when we plug in 1, it says that the 7th Fibonacci number is 4 times the 4th Fibonacci number plus the first one. And I've just written a bunch of these. In particular, I've gone down to pk, which would say this thing down here, and I've gone 1 up from it. And I've actually gone 2 up from it. I've written in a bunch of different statements because what we're going to use is strong induction. The way that strong induction works is we assume the statement starting from the beginning all the way up to the last case we checked, and we can think of all of those as tools that we can use. Now separately, we have a goal, which is to show the next statement is true. So our goal is to show that f of k plus 7 equals this thing over here. Let's look at fk plus 7 and think about what it is. Well, it's a Fibonacci number, and so by the definition of Fibonacci numbers, it's going to be equal to the sum of the previous two. But now, what about fk plus 6? Well, I have some information about that. My tool says that f of k plus 6 is going to be this thing over here on the right, so I can substitute that in, and I can do the same thing for f of k plus 5. So my reason for doing this is from the tools, and now I can just keep going. I can do a little bit of regrouping, pull out that common factor of 4 from those two terms, put the other two terms at the end, and at the end I get this statement, which sure enough was the right-hand side of my goal. Now since I use 2 different tools, in other words I use 2 lines from this list, I need to make sure that I have at least 2 base cases because I need at least 2 different tools. And so we need to verify base cases P1 and P2, which we will now do. Pause the video and check that these are the right numbers in our Fibonacci sequence. And altogether, that is how we could write down a proof of the statement using strong induction.